All right. Hey guys. So we've been spending a lot of time focusing on factoring some pretty simple trinomials where they start with x squared or whatever the variable is squared. And even if there was a coefficient, we progress to, if there's a coefficient, factoring that coefficient out. So now we're going to come across problems where I see a leading coefficient of 3 and I say to myself, okay, I'm going to try to factor that out. Oh darn, 3 doesn't divide 14 and it doesn't divide 5. So that strategy is not going to work this time. So there's two strategies that I'm going to show you to try in order to be able to factor this trinomial into two binomials. The first strategy we're going to talk about is trial and error, and it's exactly what it sounds like. Okay? So first of all, I'd be thinking of the factors of 3. Okay, so that would be 1 and 3. And then I'd be thinking of the factors of 5. Okay, so that would be 1 and 5. And I've got n and n. The sign here is a minus sign that tells me my signs are different. And now I just start plugging in numbers to see which combination of numbers works. In other words, I'm going to put 1s or 3s in front of my n's to make the 3n squared, or I'm going to make 1s and 5s as my second term of my binomials to try to make that minus 5 at the end. So I might try putting the 3 here, oops, the 3 here and the 1 here, okay, and maybe I would try the 5 here and the 1 here. Okay, so I know if I double distribute, 3n times 1n is going to be 3n squared, and I've set it up to get a minus 5 at the end. So the way that I've plugged in numbers, I know my a term and my c term are going to work. Well, now what I'm checking is, does the way I've arranged these numbers give me a plus 14n in the middle? So I'm not going to fully double distribute this. I'm just going to do the parts of it that give me the middle term. In other words, the plus 5 times the 1n, so that's be plus 5n, and the 3n and the minus 1, that makes minus 3n. And then I want to see, well, if I combine those together, would that be plus 14n? Ooh, no, it's not. So I've tried, I've gotten an error, that's why this is called trial and error, so that did not work. Okay, I'm going to try switching something. What should I switch? Okay, maybe I will try the 5 here and the 1 here. Okay, so that gives me a 1 times 1n, which is 1n plus 1n, and a 3n times the minus 5, that'd be minus 15n. Okay? Oh no. Okay, nope, we still combine those together and don't get plus 14. We do get minus 14, which tells me that the only thing I really have to do differently is switch these signs. And then I would get a minus 1n for the middle two terms and a plus 15n for the outer two terms. Now, 3 and 5, excuse me, don't have a tremendous amount of factors. And so it didn't take too long to do trial and error for that. However, if we look ahead at a different problem, if we were to look ahead at this problem with the 12 and the 15 in it, I have lots of combinations for 12. 1 times 12, 2 times 6, 3 times 4. 15, I have 2 combinations for that, 1 times 15 and 3 times 5. So there are like tons of possible combinations that we would have to try through trial and error to make this work. So trial and error is okay, but it can get, the larger your numbers get, the more time consuming that can be. So we don't necessarily want to always do that. So we have an alternative method that you can use. So going back to this problem, okay, we came up with the final answer. Let me erase some of these extraneous markings here. Of, there we go, 3n minus 1 and 1n plus 5, and that's what ends up working in this problem. So if you didn't want to do trial and error, there's another method, okay? The other method, I don't know that there's a specific name for it, okay? But here's the steps. Step 1, multiply A times C. So 3, and we'll worry about signs later, okay? So don't worry about signs right now. 3 times 5 is 15. Okay? Then make a list of the factors of 15. So 1 times 15, 3 times 5. Okay? So 1 times 15, 3 times 5. What I'm looking for is the pair of factors that's going to subtract to make 14. So that would be 1 and 15. Okay? Next, I'm going to start setting up my binomials. But here's where there's a trick to it. Okay? I know that I need this coefficient to be a 3. And one of these binomials is going to have a 3 in it. But I don't know which one. So for the time being, I'm going to put it in both. Now, how do I get the 14, a plus 14 specifically out of 1 and 15? It would be a minus 1 and a plus 15. So minus 1 and a plus 15. And I'm just going to plug those in. Next, that didn't go in there. Now, remember how I put a 3 in both trinomials? Well, that can't stay that way. I put an extra 3 in. I need to find a way to get that extra 3 back out again. So what I'm going to look at is each binomial separately and see if I can factor out anything. So 3n minus 1, nothing factors out of that, so that will stay. But 3n plus 15, I can factor out a 3. Now, when this factors out, it's factoring out. In other words, it's not something like factoring out a leading coefficient where I have to carry it down. It wasn't supposed to be there in the first place, so we're just factoring it back out again. So if I factor a 3 out here, I've got n. 15 divided by 3 is 5. And there I get my answer. Let's practice that again with this guy. It's pretty big one, pretty big problem right here. Okay. 12 times 15 is 180. So I'm first multiplying 12 times 15. Okay, then start the factors of this. 1 times 180, 2 times 90. Gosh, this factors list seems like it might get pretty long. Well, don't forget the hack that I've shown you in class, which means I don't have to really write it all out. I can type in 180 divided by x into my y equals, go to my table, and I start seeing all the factors of, come back, 180. Okay, I'm only going to pay attention to where I've got whole numbers, no decimals. So 1 times 80, 2 times 90, 3 times 60, 4 times 45. And all I am looking for is the row in the table that subtracts to 8. Right here, 10 and 18. So it's really not necessary to write out the entire list, especially when it's that long. 10 and 18 is what I want. Okay, so how do I make a plus 8 with a minus 10 and a plus 18? So now I'm going to write two binomial pairs. Put a 12 in both of them. 12x, excuse me. Then make one of them minus 10 and one of them plus 18. And then now we're going to factor this. Now each one of these factors, but they don't factor by 12. Okay, so for example, this first one, okay, 12 and 10 both factor out a 2. And when this factors out, it's gone. And I get 6x minus 5. 12 and 18 both factor out a 6. And I get 2x plus 3. And then this would be my final answer. Okay, and just to make it make sense for you, see how we put a 12 here and a 12 here? Okay, we got an extra 12. They shouldn't both be 12s. Okay, so I put an extra 12 in, and by factoring out a 2 and a 6, factoring is related to multiplication. By factoring out a 2 and a 6, I factored one of the 12s back out. I just didn't factor it out of one of the binomials. I factored a piece out of each one. If you are ever not sure if you did this correctly, if your answers are correct, go to your y equals and type them in. So y equals 12x squared plus 8x minus 15. Then type in what you got for an answer. So 6x parentheses 6x minus 5 and 2x plus 3. Now, don't look at the graph because sometimes the graph won't show up. Look at the table. And as long as your y1 column and your y2 column match, you did it right. Okay, then they don't match, it doesn't tell you what's wrong, but at least it tells you you did something wrong. And to go back and check your work. Okay, one last thing is if you have a negative leading coefficient, and this goes all the time, not just this situation, but if you have a negative leading coefficient, factor out the negative. Okay, so negative factors out, and I get positive 8x squared minus 6x minus 5. Okay, now this negative that I factored out, I have to keep. But then I'm going to go from there and I'm going to carry it down, but I'm going to ignore it now. So 8 times 5 would be 40. And we need numbers that subtract to 6. So 1 times 40, no. 2 times 20, no. 4 times 10, okay, that subtracts to make 6. In fact, we want a minus 6, so it'll be a plus 4 and a minus 10. So we've got 8x and 8x plus 4 minus 10. And here again, I'm going to factor out of each one. Factor out wherever I can. So 8 and 4 both divide by 4. So I will take a 4 out. And I will get, carry the negative down, 2x plus 1. In my second binomial, these both divide by 2. So I get 4x minus 5. Okay, so this ends up being my final answer. Thanks for watching. Have a great day. See you next time.